9. Inverse trig functions. So this lesson's all about how to use inverse trig functions to solve equations. Now here's the first thing you need to know about inverse trig functions. They have very specific domains. It's like right here, this is inverse sine, right? So you notice that normally it's y equals sine x. It looks like this, starts in the middle, goes up, goes down. This doesn't look like that because we did the inverse. We switched x and y, so you can see right there. And you get the graph that looks like this. What's the problem with that? It's not a function, right? It doesn't pass a vertical line test. So when we talk about inverse functions, we're only talking about this very specific domain from here to here that makes it a function. So for sine inverse, or arc sine, we're only going to look at the first two, or we're going to look at quadrant 1 and quadrant 4. So this is, if sine inverse is positive, it's right there, negative right here. That's actually the same thing for tan. And inverse tan would look the exact same way. And then cosine, and I'll show you a graph of inverse cosine in a second. We're only going to look at the top, quadrant 1 and 2. So plus b here, minus b there. Again, this will all make more sense in a little bit. But the general idea is, when you graph an inverse trig function, it's not a function. So we got to restrict the domain so it makes it a function. And when that happens for sine, you can see it goes from negative pi over 2 to pi over 2, which is negative pi over 2 is down here, pi over 2 is up there. When we do for cosine, it's going to go between 0 and pi. So this says the same thing. So that's the key thing to keep in mind. I'll write it again right here. Inverse sine or arc sine and arctan are both going to be in quadrant 1 or quadrant 4. Positive in quadrant 1, negative in quadrant 4. Arc cosine or inverse cosine is in the top half. Quadrant 1 or quadrant 2. And then the idea with inverse is that you go backwards, right? So if I said, what is sine of pi over 4? We're going to go rad 2 over 2. Well, inverse, we're going to go backwards. I'm going to give you sine inverse of rad 2 over 2, and I want you to find the angle. I want you to say pi over 4. What angle gives me that answer? So that's what we're going to do here. So best way to do this is by some examples. So write each value, find the angle and measure in degrees and radians. So how are we going to do this? Well, first, draw it. So we're doing cosine inverse. Cosine inverse is only the top half, plus and minus. Now, this is a negative 1/2. So we're going to draw, when I say draw, I mean draw a triangle. The correct quadrant. So we're going to draw a triangle in the proper quadrant. So in this case, we're negative, and we're doing cosine. So cosine top half, and it's negative, so we're going to draw a quadrant thing in quadrant there. Okay. And then you can use a table, or you can use a triangles, right? If you're team table or team triangle, to figure out the reference angle. To find reference angle. So if you're doing table, just look at your table and see where does cosine equal to 1/2 at. That's all you got to find out. If you're doing the triangles, well, we're going to do SOHCAHTOA. So negative 1, 2. That makes the missing side rad 3, which makes this a 60-degree angle. So again, I don't care how you do it. Either you can use a table or you use triangles, but you got to figure out that this is 60. Now we're almost done. I got to find the angle out. So the answer's not 60 because remember, we always start from here. So if that's 0, this is 180. This is going to be 60 short of 180, so like you're 60 away, which is 120 degrees. Right, so where does cosine equal negative 1/2? At 120 degrees. Now that's in degrees. What if I want radians? Well, the key thing is 60 degrees. Remember, 60 degrees is pi over 3. And if I'm doing this, remember pi over 3, we're going to make this 3 over 3. So 1 less would be 2 pi over 3. So that's how you find degrees, and that's how you find radians. But that's the general idea. We're going to draw a triangle in the proper section, then we're going to use a table or triangles to figure out the reference angle is. And once you do that, you're done. You get your angle, put in degrees or radians. Best way to do this is to do lots and lots of examples. So let's do this next one. Sine inverse of negative 1/2. Now sine, like tan, is only in the quadrant 1 or quadrant 4. This is a positive, so we're going to do it in the quadrant 1. Negative would be down there. Sine is 1/2. So again, any way you want to do it. Look at your table or do a triangle. Any way you want to do it. So I was doing a triangle be this. Now, again, if you're doing a triangle, keep in mind that's 1, 2. That's not 1, 1, rad 2. This is a 30-degree triangle. Because that's not a radical, so I know it's not 45. So that angle is 30. So that is it for that one. That's just 30 degrees. You don't go over, it's just right there. In radians, 30 is pi over 6. So pi over 6. Arctan of 1. Now we gotta watch out. 1's generally a special one. Now first, plus and minus. 1's usually on these things, right? Or if you look at your table, sine and cosine, it's pi or 0. Not in tan. Tan could do 1. Positive, first of all, so quadrant 1. Tan, we can do 1 over 1. Again, if you're doing the table, just look for a table. Where does tan equal 1 at the table? If we're doing triangle, it's 1, 1, which makes this rad 2, which makes this 45. So again, any way you want to do it. If you do the table, look for where does 1 equal tan on your table. It's like, oh, 1 is 45. And if we're doing radians, pi over 4. Arctan and negative rad 3. So let's do that. Remember again, tan and sine are both can't be on this side. It has to be here. Quadrant 1, quadrant 4. This is a negative, so we're in quadrant 4. And like I've been saying, so if you do a table, look at the table. Here's tan. Tan, it goes like this. I'm trying to remember off the top of my head. And undefined. So you'd be like, okay, tan is rad 3, so there's rad 3, which would be 60. So again, if you're doing a table, that's how it kind of work out. If you're doing a triangle like me, because I'm team triangle and I love triangles, I go TOA, opposite over adjacent, so my opposite's rad 3. That pretty much tells me all I need to know. If I know the opposite's rad 3, I know rad 3 is 60. Right? The key thing for triangles is knowing the opposite, because that tells you what the angle is. So 60 degrees. And actually, I'm wrong. We're going down. Negative 60 degrees, right? Because we went down. Now we can't go, it's not 300, you're not going all the way around because you can't hit a wall here. So you went down, you go down to negative. Or negative pi over 3. Last one of these before we move on to the next thing. Arc cosine of negative 1. Cosine, top and bottom. Where's cosine equal 1 at? Now this is tough. If you look at your table, there's gonna be not the only you're actually gonna have a 1. You have a positive 1 right here. If we do the table for cosine, but you have a negative 1. So remember, anytime it's the opposite, you just go the opposite way. Anyway, if we're doing the triangle, you're like, wait, there's no triangle that makes it 1, because if you do TOA, that's not a triangle that we know. There's no adjacent and hypotenuse that are the same. So you gotta remember that in this case, it's one of these points. Always the hardest thing about the triangle is what do you do when you hit the line. So this point is 1, 0. This point is 0, 1. This point is negative 1, 0. Cosine, so sine e, sine's the y value. Cosine's the x value. So where does the x value equal negative 1? And that is right here at 180 or pi. So again, that's always the toughest one for a triangle, is figure it out when it falls on the line. It's like memorization. If you're doing a table, you're not going to have negative 1 on the table, you're going to have 1 on the table, and you just go on the other side. So here's 0, go on the other side, 180 or pi. Okay, so that's that stuff. I think that's probably the hardest stuff today. Next part is my favorite part of today. So this part is find the trig value of tan of cosine inverse of negative 1/2 round to nearest hundredths. So we're not even going to do that part. We don't need that. We want fractions. So this is what we're going to do. This is one of my favorite things to do in trig. So find tan of this. So what we do is this. We use this to make a triangle. So use inside to make triangle. So notice how in all these insides the inverse function. So we use the inside to make a triangle. And then we're going to take the outside. What I mean by that is we're going to take whatever tan, sine, or cosine, we're going to take the outside function. Take outside function of the triangle. That's generally going to be SOHCAHTOA, but that's all we're going to do. The general idea, guys, is make a triangle with the inside and take the outside function of it. So like here, cosine inverse of 1/2. Remember, cosine could either be quadrant 1 or 2. This is positive, so quadrant 1. Now in this case, I'm not going to do table, haha table. We're going to make a triangle. SOHCA TOA. So cosine equals 1/2. Cosine inverse equals 1/2. SOHCA TOA. So my adjacent's 1. My hypotenuse is 2. Now I can find the missing side by doing a squared, b squared, c squared. In this case, I actually know this triangle. That's not always going to be the case. You'll see with the next one's not the case at all. This will be rad 3. So I just did 1 squared plus b squared equals 2 squared. And you get rad 3. So that's it for the inside. All I do now is, what is tan of that triangle? Well, TOA. Opposite over adjacent. Rad 3. And that is it. That's literally all you have to do, is make a triangle with the inside, find the outside. So let's do another one. Or 2. Right, so in this one, same idea. Tan inverse can only be in quadrant 1 or 4. This is positive. So I do this. TOA. So opposite over adjacent. So this is 3 and this is 8. And I am done with that part. I just got to find side of this triangle. Well, I don't have the hypotenuse, so we got to find the hypotenuse first. So use Pythagorean theorem. 3 squared. Remember, this is always c. So 3 squared, a squared plus b squared equals c squared. 9 plus 64 equals c squared. 73 equals c squared. C equals radical 73. And then if I want sine, it says so. Opposite over adjacent. And that's the idea, right? Let's do one last one of this because it's so easy. I like it so. Arc sine of 4/5. So again, same idea. Can be quadrant 1 or 4. Positive to quadrant 4. Sine is 4 or 5. SOHCA TOA. So 4 or 5. Look at this one. We're in this one. Look how easy that is. We know what that triangle is. It's a 3, 4, 5 one. Done. Do cosine of it. SOHCA. Adjacent right hypotenuse. 3/5. Done. Okay, the last part of this is just kind of review. We talked about how to do this before. The way we solve this is they want us to use a calculator, so that's all we're gonna do. So find sine theta if equals that. I said that terribly, but whatever. They want us to solve it. So the way you get rid of sine is we're gonna take sine inverse of both sides. So for that first one, remove over my calculator. Come on. So turn on my calculator. Now right now I have it in radians, I believe. Oh no, it's in degrees. How nice. You probably want in degrees so it'll make the answer make more sense to you. So second sine, that's how you get the sine inverse, second sine. Then negative 0.35. And I get about negative 21 degrees, 20.5 degrees. So that's my theta. You can also do in radians and you get the right answer. It's just will be something ugly that you won't understand. Right, same thing here. Do tan inverse of both sides. Put in your calculator and get an answer. I'm going to skip that because who cares. Hey, look at an application problem. Right, they want me to find theta. And all I have to do here is label the sides. So here's my angle. This is opposite. This is adjacent. So opposite adjacent's TOA. TOA. There we go. So tan of theta equals 5 over 15. You want to get rid of tan, do tan inverse of both sides. Put in your calculator, get an answer, blah, 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 blah. Right? Last one we're doing today, then we're done with this video. Right? Same idea. There's your angle. Opposite. Adjacent. Hey, it's another tan. Man, they're not very. 6.2 over 18. Again, going to get rid of tan, do tan inverse of both sides. And we are done. And there we are.